Hello guys, welcome to our session. It's Niaki Osteozone, right? So today we're going to have a discussion on the May-June 2023 paper 1-2 of the Cambridge Exam Board O-Level Chemistry. So I will guide you through the chemistry paper, and we are going to break down the key concept together, focusing on understanding rather than memorizing answers, and also to prepare you to tackle your exam questions with confidence, right? So you need to take note of these instructions if you're doing the Cambridge Exam Board. But if you're not doing Cambridge Exam Board, what you only need to do is to pay attention to data, because here you don't focus on exam boards. What you only need is data to answer these questions, right? So we're now moving on to the first part of the paper. So the first part says a sample of iodine at room temperature and pressure RTP, right? So which statement about the particles is correct, right? So we've got a sample of iodine at RTP, and then we are required to provide the correct statement. So for multiple choice paper, we use the method of elimination to find the most appropriate answer, because some of the answers may sound to be true, but we need to carry out a forensic analysis so that we can eliminate these answers, right? So the first part says the particles are arranged in a giant lattice. So this is false. Iodine is a simple covalent molecule which exhibit a simple lattice structure, simple molecular lattice structure, where the particles are held, or where the molecules are held by the weak van der Waals forces or the London dispersion forces, right? The induced instantaneous dipole moments, right? So these are the forces found in the lattice structure of iodine. So this becomes false. And then the particles have a zero kinetic energy. So the particles are in motion, but with a little amount of kinetic energy, right? So they vibrate on fixed positions, right? So this becomes false, right? And then the particles move randomly through the solid. So this is also false. The particles vibrate on a fixed point, right? On a fixed position, right? And then the option D says the particles vibrate about a fixed point. So this becomes true. And then on number 2 says element Z has got the nucleon number 31, and then the ion Z 3 - 3 charge. So where is Z found in the periodic table? So the nucleon number is defined as the sum total of the protons and the neutrons in the nucleus of an atom. So as I've alluded to in our previous sessions, we did the subatomic particle. So the subatomic particle with the subatomic table here, and then the electrons, the protons, and the neutrons. And then we learned that mass 1/1840, the mass. So in the discussions, what we do, we don't stick to the given questions, but we try to attempt any related or any concept within the given radius, right? So we want to dwell more on the subatomic particles, because these are being examined here, right? And then the mass of the protons, we got 1 unit, and the neutron 1 unit, and then the charge negative, positive, and then this one is uncharged. And then the location, nucleus, as in the shells, electrons are located in the shells, and then protons in the nucleus, and then neutrons in the nucleus to give the nucleon. So the nucleon is what we call the mass number, and then we can write Z in the nuclide notation A, B. So for a neutral atom, the number for a neutral atom, the number of protons is equal to the number of electrons, right? And then for a charged particle, for an anion, the number of protons, anion, the number of protons is less than the number of electrons. And then for a cation, the number of protons is greater than the number of electrons, right? So B is the mass number or the nucleon number, and then A is the proton number, the atomic number or the number of electrons, which is equal to the number of protons for a neutral atom, right? So that is what you need to know for the subatomic particles. In the previous discussion, we did the deflection within the electric field and the magnetic field. The electrons being deflected to the positive electrode, and then are deflected first because they are lighter, and then the protons lastly to be deflected because they are heavier, deflected to the negative terminal, and then the neutrons are remaining undeflected, right, because they are uncharged. So this is what you need to know for your subatomic particles, right? And then the question says, where is Z located with the nucleon number 31 and the ion with the charge 3 minus. So 3 minus simply means that Z gains 3 electrons to attain the stable noble gas electronic configuration. So the stable electronic configuration is what we call the octet rule, right? Where we are going to have 8 electrons in the valence shell, right? So Z needs to gain extra 3 electrons to have 8, meaning to say originally Z has got 5 electrons in the outermost shell. So what denotes the valence shell is what we call the group. So the group number is equivalent to the valence shell, right? So Z originally has got 5 electrons in the outermost shell. So it gains 3 electrons to attain a stable noble gas electronic configuration like that of argon, that of neon, right? So Z is in group 5. So this is true. Z is in group 3, false. Period 4, we are not given information which we can use to find the period. So period is given by the number of shells, right? So we are not given information which can lead us to the period of the element Z, right? So B is the correct answer. And then we're now moving on to the next question, which says naturally occurring bromine has a relative atomic mass of 80 and consists entirely of 2 isotopes of relative atomic masses of 79 and 81. So this is what we call the relative isotopic. So this one should be isotopic, not atomic. So this is very wrong. It's relative isotopic mass, right? Not relative atomic mass. So we can continue by reading the question, which says what can be deduced about naturally occurring bromine from this information only. So we need to highlight this word only. So we are going to use this given information only, right? The relative isotopic masses and the relative atomic masses, right? So for the first option says bromine contains 2 isotopes in equal proportion, right? Bromine contains 2 isotopes in equal proportion. So we've got 2 isotopes, one with relative isotopic mass of 79 and the other with relative isotopic mass of 81, right? So this is very correct. They are in equal proportion. We can simply calculate the relative atomic mass by adding using the formula AR is equal to isotopic mass, relative isotopic mass multiplied by abundance. So we need to define what is abundance, and then over total abundance, right? Over total abundance. So here we can simply add the 2 relative isotopic masses and then divide by 2, and we are going to have 160 over 2, which will give us 80. So this simply means that the 2 isotopes are in equal proportion. They've got the same abundance being defined as the percentage in which the isotope is found in the natural occurring element, right? And then relative isotopic mass can be defined as the mass of an atom, of an isotope measured relative to 1/12 mass of a carbon-12 atom. And then you should be able to define the term relative isotopic mass, right? So you need to familiarize yourself with the definitions, because they might come in your structured paper and even in your multiple choice paper, right? And then we move on to option B, which says bromine has different oxidation state. So from this given information, we cannot deduce the oxidation state because we are never told anything about the electrons, right? So we can't tell oxidation state without mentioning electrons, right? So this becomes false because we are sticking to this condition only, right? And then bromine isotopes have a different number of protons. So isotopes are defined as atoms of the same element with same number of protons and same number of electrons, but different number of neutrons. Meaning to say we have got different mass number, right? The nucleon number, right? So this is very false. And then bromine is radioactive. We cannot conclude that using this given information. So this becomes false. So we are now moving on to the next equation, number 4. So number 4 says element X and Y react together to form a compound. And then the electronic configuration of X and Y are given. This is the electronic configuration of X. And then this one is the electronic configuration of Y. Which row shows the electron transfer that takes place and the type of the compound formed? So the electronic configuration shows that the element X is in group 3. By we can check on the valence number, the number of electrons in the outermost shell. We got 3, right? So meaning to say it is in group 3. It reacts by losing 3 outer electrons to attain stability, the electronic configuration, that of a noble gas. So we're going to have an ion with this formula, right? And then Y is in period 2 in group 6, meaning to say Y needs to gain extra 2 electrons to attain stability, right? So Y is an anion and then X is a cation, forms a cation, right? So Y forms an anion with this formula 2 minus. And then the formula of the resultant compound is given by X2 and then Y3. So we exchange these coefficients here. 2 goes here and then Y goes there. So you can use magnesium and chlorine. The 2 goes here and then the 1 goes there. We have this resultant compound. So this is how you can write your formulas for ionic compounds. So I've done this in my previous series, so you can go and check on our playlist. And also remember to comment wherever you feel like you need our attention. So this is the formula of the compound that is formed. So we can now go to the statements and try to see which is which, right? And then the first option A says 2 atoms of each X loses 3 electrons, right? So X loses 3 electrons. This is true. And then we've got 2 atoms of X from the formula, right? This is very true. And then element Y, 3 atoms of each. So we've got 3 atoms of Y and then receives 2 electrons. So this is very true. But the type of bond, this is very wrong. Electron transfer is done during ionic bond, where one atom loses electrons and the other receives electrons. So this is ionic bonding, not covalent bonding. So covalent bonding is defined as the type of bond formed when two atoms, non-metals, came together to share electrons to achieve the stable noble gas electronic configuration. So we go on to option number B, which says 2 atoms of each loses 3 electrons, true. And then 3 atoms of each receives 2 electrons, true. And then we've got ionic bond, which is also true. And then we go on to option C, which says 2 atoms of each receives, so this is false. X react by losing electrons, so this becomes false. 2 atoms of each receives, this becomes false, this becomes false, and then this also becomes this is true, this is true, but this becomes false. So the overall solution, we've got B as our answer, right? So we now move on to number 5. Which molecule has the largest number of electrons involved in the covalent bonds? So what we are going to do, we are going to write the displayed formula for each and every molecule and then count the number of electrons in each of the covalent bonds. So we've got ethene with this displayed formula. We've got H here, and then H here, and then H here, and then H here. And then we've got carbon dioxide with this linear shape, right? And then we've got methanol, right? And then H here, and then H here, hydrogen, right? And then we've got nitrogen with the triple bond. So there's this question oftenly examined for nitrogen, which says, why is nitrogen unreactive? Why is it inert? Why is nitrogen an inert molecule, right? This is due to the nitrogen triple bond, which is difficult to break, with a lot of energy being required to break this one more of this covalent bond. So the bond energy is defined as energy required to break one more of a covalent bond in gaseous phase. So the energy required to break this covalent bond is very, very large, right? So this is why nitrogen is very, very unreactive. So we're going to count the number of electrons. Each single line represents a single pair of shared electrons, meaning to say we have got 2 electrons here, 2 electrons here, 2, 2, 2, 2. So each line or each bond represents 2 electrons, right? So we've got 2, 4, 6, 8, 10, 12. So we've got 12 here, and then here we've got 2, 4, 6, 8, and then 8 here, 2, 4, 6, 8, 10, then 10 here, 2, 4, 6, then we've got 6 here. So our correct answer is equal to A. So we can now proceed to number 6. So number 6 says X is the arrangement of bonds around a carbon atom in graphite. And then Y is the arrangement of bonds around the carbon atom in diamond. So Z is the arrangement of bonds around a silicon atom in silicon dioxide. So which arrangement of bonds are the same? So you should know the relationship between graphite and diamond. So graphite and diamond are what you call allotropes, right? So these allotropes are defined as atoms of the same element, but different arrangement of particles in the lattice structure, right? These are atoms of the same element with different arrangement of particles in the lattice structure, meaning to say the physical properties may differ with regards to each and every molecule, right? So the arrangement in the graphite molecule, graphite uses what you call the sp2 hybrid orbitals, and we are left with an hybridized p orbital, which can overlap with other unhybridized p orbital to form a sea of electrons between the layers, right? So the arrangement in the graphite, we've got it is a trigonal planar arrangement, right? And then for diamond, we've got a tetrahedral arrangement. And then for silicon dioxide, we also have a tetrahedral, right, arrangement of particles. So here I've got 3 bonds, and then you've got 4 bonds, and then you've got 4 bonds. So each silicon atom is bonded to 4 different oxygen atoms, and then each oxygen atom is bonded to 2 silicon atoms, right? Each silicon is bonded to 4 oxygen, and then each oxygen is bonded to silicon. So you should take note of this one, right? So which arrangement of bonds are the same? So the same we've got on X and on Y and then on Z. So our correct answer is equal to C, right? C is the correct answer. And then we now move on to number 7. Number 7 says, what is the equation for the reaction between sodium carbonate and dilute nitric acid? So the reaction between an acid and a carbonate, we form salt plus carbon dioxide plus water. So we're going to write this equation. So it's sodium carbonate. So here being examined on how to write your chemical formulas and to balance chemical equations, right? So we've got sodium nitrate plus water plus carbon dioxide. So to balance this equation, we're going to have a 2 here and then also a 2 here. So this is balanced. So for option A, this is not the formula of nitric acid. This is very wrong. And then option B, this is not the formula of sodium carbonate. This is very wrong. And then for option C, this is also very wrong. And then we are left with option D. So we want to stick to the method of elimination so that we can understand why we choose our answer, right? So on number 8 says, which statements about relative atomic masses and relative molecular masses are correct? So we have defined relative atomic mass in our previous questions, and then we want to define the relative molecular mass. So relative molecular mass is defined as the average mass of a molecule measured relative to 1/12 mass of a carbon-12 atom, right? So this is the definition of relative molecular mass. So the first statement says the mass of the different isotopes does not affect the relative atomic mass. The mass of different isotopes does not affect the relative atomic mass. So this is very wrong, right? The mass of the isotopes is what we call the relative isotopic mass. So relative isotopic mass. So the sum total of the relative isotopic masses being multiplied by their abundance over total abundance is what we have the relative atomic masses. So to calculate the relative atomic masses AR, we say relative isotopic mass multiplied by abundance over total abundance. So as you can see from this equation, relative isotopic mass is one of the crucial constituents of IR, right? And then this makes this statement false. And then we want to move on to statement number 2. Only covalent bonds have relative molecular mass. Only covalent bonds have relative molecular mass. This is true. For ionic bonds, we have what we call the relative formula mass. So relative formula mass is same as relative molecular mass, but what differs is that relative formula mass is found in ionic compounds, and then relative molecular mass is found in covalent compounds. So relative formula mass is defined as the average mass of formula units in a compound measured relative to 1/12 mass of a carbon-12 atom, right? The average mass of the formula units in a compound measured relative to 1/12 mass of a carbon-12 atom, right? So this is the definition of the relative formula mass. And then the statement number 3 says relative atomic mass are compared to 1 over 12 mass of a carbon 12 atom. So this is very true. So we've got option 2 and 3. So the correct answer is equal to C, right? So we are now moving on to number 9. So number 9 says, let me clear the question so that we can proceed, right? So the answer was C. So number 9 says aqueous hydrogen peroxide decomposes slowly at 25 degrees Celsius. And then we have got this equation for the decomposition of hydrogen peroxide. The decomposition takes place faster when a catalyst is added. A student adds small amount of a catalyst to 10 cubic centimeters of 1 mole per cubic decimeter hydrogen peroxide, and then collect the gas formed. The volume of the gas collected was 90 cubic centimeters. All measurements are at RTP, room temperature and pressure. And then we are required to calculate the percentage yield of oxygen gas. So percentage yield is equal to actual over theoretical times 100. So this is the formula of the percentage yield, right? And then you want to explain on this underlined facts, underlined terms, right? So the term catalyst, a catalyst, it is a substance which speeds up the rate of a chemical reaction. So it speeds up the rate, of a chemical equation, right? So it speeds up the equation, the reaction, by providing an alternative route with lower activation energy, right? So it provides an alternative route with lower activation energy. So the catalyst doesn't lower the activation energy. You need to take note on that one. It doesn't lower the activation energy, but it provides an alternative route with lower activation energy, right? So that's the catalyst. And then activation energy defined as the minimum amount of energy needed to start a chemical reaction. And then the reacting particles, in order for them to collide in the correct orientation with the sufficient energy, they must have the energy which is above or equal to the activation energy, right? And also, what else do we need to? So we've got this this graph. So you can be examined on this graph, the energy change profile, right? So you've got the reactants here, then the products here, meaning to say this reaction is an exothermic reaction. Some of the energy is being lost to the environment, right? So here is the uncatalyzed, and then here is the catalyzed reaction, and then you have got the reactants, and then here the products, and then this is the enthalpy change, the energy change for the reaction, right? So this is the enthalpy change, and then this is the activation energy, right? This is the activation energy. This is the uncatalyzed reaction, and then this is the catalyzed reaction. So you need to take note on this graph, right? You need to know this graph inside out, right? And also this curve. So this is the volume of oxygen produced, and then here we've got the rate of the reaction, right? So the volume remains constant at a given point, but this equation, which is steeper, is the catalyzed reaction. Then this one is the uncatalyzed reaction. So you should take note on these two curves, right? So we are now moving on to the question for this paper, right? So here we are being examined on the percentage yield, right? So for the percentage yield, we are going to write this equation for the reaction: 2 moles of hydrogen peroxide having 2 moles of water plus 1 mole of oxygen. So 2 moles of hydrogen peroxide will give 1 mole of oxygen. So we want to calculate the number of moles that reacted here. So we've got 10 over 1000 cubic decimeters. So N is equal to CV, right? So you should always remember these fundamental equations, right? N is equal to CV. So this one is our V, and then our C is equal to 1. So it's 1 is equal to 10. So you can go straight to our calculator. 10 over 1000 multiplied by 1. So we are having 0.01, right? So these are the number of moles of hydrogen peroxide that reacted. So it's 0.01. So 2 gives us 1. What about 0.01? Gives us less, right? So we're going to have 0.01 over 2 multiplied by 1. So divided by 2 multiplied by 1. So we're going to have 0.005 moles, right? So these are the moles of oxygen produced. And we are told that this reaction, all the measurements were taken at RTP. So at RTP, 1 mole of a gas occupies 24 cubic decimeters, right? And then 0.005 occupies less. So it's 0.005 over 1 multiplied by 24. So we're going to have 0.12 cubic decimeters, right? So this is the theoretical amount of oxygen that was supposed to be formed. But we formed 90, actually we formed 90 cubic centimeters. So the formula of finding the percentage yield is actual amount formed over the theoretical, which was supposed to be formed, multiplied by 100. So we've got the actual being 90 cubic centimeters. To change it to cubic decimeters, we divide by 1000, right? So we've got 90 divided by 1000 to have 0.009 over 0.12. This 0.012, the theoretical value, multiplied by 100. So it's divided by 0.12 multiplied by 100. So we're going to have 75%. So the correct answer is equal to 75%, which is on D. And then so you need also to know the percentage purity. So percentage purity. So in our next session, we're going to have a discussion on percentage purity. So always remember to subscribe and stay tuned to our channel, right? So we are on number 10. So number 10 says the diagram shows the structures of the atoms of X and Z. These are the two elements, X and Z. And then X and Z are not the atomic symbols for these elements, right? And then the question says the elements combine to form a compound. What is the mass of 1 mole of this compound? So these two combine to form a compound. So you should also be able to define the term a compound, right? the compound, the mixture, the element, the atoms, right? So you should be able to define these terms for structured paper, right? So first we need to find a formula of the compound to be formed, right? So we've got two electrons here to make the duplet state. The first is, shell is filled with two electrons, the duplet state like that of helium, the noble gas, right? So what is wrong here is that the electrons are spaced to minimize mutual repulsion. So the electrons in the first shells must be spaced to the opposite poles to minimize mutual repulsions, right? So for the orbitals, each orbital can hold a maximum of 2 electrons with different spins to minimize what you call the interelectronic repulsions or the mutual repulsions. So the electrons must be spaced, right? So you need to correct on that one when drawing your dot and cross diagrams, right? And also, we're going to count the number of electrons in the outer shell, the valence shell. We've got 1, 2, 3, 4, 5, 6. So the electronic configuration is 2 and then 6. And then we're going to 2 here and then 1. So this is the electronic configuration of this element. So X will lose this outer electron to have, so we're going to have this ion X plus. And then Z will gain 2 electrons to have 8 electrons in the outermost shell, meaning to say the formula is equal to Z2 minus. And then the compound formed is equal to X2 and then Z, right? So here we've got Z, not Y. X2Z, right? X2, X2Z. So we're going to have the relative atomic mass of X times 2 plus the relative atomic mass of Z. So the mass number or the nucleon number of X is equal to 7, the sum total of protons and neutrons. Electrons doesn't take part in the nucleon number. Why? Because they are negligible with a mass of 1 over 1840, right? So we've got 7. So it's 7 by 2. Since we have got 2 atoms of X here, 7 by 2 plus Z. So for Z, we've got 8 plus 8, which is equal to 16, right? So this one is equal to 14 plus 16, which is equal to 30. So the correct answer is equal to D. So